Hello friends, welcome to UGC EPG Pathshala. I am Dr. Prabodh Kumar Mishra from Department of Geography, Shivaji College, University of Delhi, Delhi. Today I am going to elaborate upon origin of air masses and their classification, which come under the paper Climatology. First of all, let us discuss what could be the learning outcomes of this module. While going through this module, you will be able to define an air mass, identify the sources of origin of air masses, explain the basis of air masses classification, distinguish between cold and warm air masses, and describe the distribution of air masses over the globe. Introduction. Air is invisible, but it can very well be felt. You are aware that the air in the tube of cycle, bike, car reduces. It is pressed due to weight of the vehicle, which clearly manifests that air occupies certain space and it has its mass. For a clear understanding of the various types of atmospheric disturbances, the study of air masses provide an essential background. Air masses that move along as a part of the large scale motion system of the general circulation are largely responsible for bringing out changes in day-to-day weather, particularly so in the middle latitudes. The temperate regions can be considered to be the battleground where air masses with contrasting physical properties very often meet. Traveling air masses transport latent heat as well as other temperature characteristics from one region to another. Air masses also carry large quantity of atmospheric moisture from over the oceans to continents to yield precipitation over there. In this module, an attempt has been made to discuss the origin and classification of the air masses. Now, air mass is an extensive body of air, usually many thousands to million of square kilometer of area. It is an integral part of the global planetary wind system that is located in a specific region on the surface of the earth and stays for a substantial period of time with horizontally uniform physical characteristics such as temperature and humidity. Generally, it occupies thousands of kilometers across, encompassing subcontinental size in expanse. It is usually almost horizontally uniform in temperature, pressure and humidity. The changes are observed with increasing altitude, which is general principle irrespective of area air masses. It is located in the specific region on uniform surface on the earth's surface. In terms of their physical characteristics, it may extend vertically up to a height of troposphere. This large volume of air stays for a substantial period of time horizontally and it attains uniform physical characteristics such as temperature and humidity. Air mass can also be defined as the body of air extending over a large homogeneous area, which is characterized by similar physical attributes like heat and moisture of the local area. The air mass which with constant contact with the underlying air of any region attains the much needed equilibrium between temperature and humidity. Such air with well defined equilibrium, distinctive characteristics and little horizontal variation is often referred to as air mass. The vertical distribution of temperature delineates the stability of air mass. Besides, the degree of hotness and coldness and moisture content in the air determines the process of condensation. It forms an integral part of planetary wind system, thus associating them with one or the other wind belt. For example, both tropical and polar belt of westerlies. For example, both tropical and polar air mass could coexist in the belt of westerlies. It is this air mass that transfer and distributes the heat from tropical to polar region and prevents latitudinal temperature imbalance. Inside the air mass, the horizontal gradient of temperature and moisture is weak, that is temperature and moisture at a given height is almost same or comparable. At the margins of the air masses, the horizontal gradient becomes sharp. Now, we will discuss origin of air masses. The origin of the air mass is dependent upon the area where it develops. Its development starts on a uniform huge area. Area where air masses are developed in a natural process is known as the source region. Air masses acquire the properties of the source region area in terms of temperature, pressure and moisture. A good source region for the air mass to develop should be a fairly uniform extensive area, relatively flat and homogeneous area with similar type of physical conditions, prevailing calm conditions, preferably high pressure conditions. Areas with regular high pressure zone of the earth atmospheric circulation is found in subtropical vertically air inside zone as well as circulation is found in subtropical vertically air subsiding zone as well as thermally induced polar zone. In these areas, the horizontal change in pressure gradient is low while the pressure itself is high. The divergent air circulation is the ideal source region for the air mass to develop as a part of relatively stable volume of air. Mid-latitudinal region is dominated by cyclonic and other local disturbances. It is practically devoid of such activities. The nature and characteristics of source region determines the characteristics of an air mass, thereby enabling the maintenance of equilibrium between heat, that is temperature, and moisture, that is humidity, with the overlying air mass. These regions are characterized by stationary or slow moving anticyclones with calm light winds. The air mass characteristics changes with distance from sources. Determinant factors of air mass. The nature of air mass is primarily determined by three factors. They are first source region, second duration of the air mass stability, and third natural changes or modification with time and space. Classification of air masses. The primary classification of air masses is based on the characteristics of the source region. They could be Arctic, polar, tropical. There are 5 major regions of air masses: warm tropical, subtropical ocean, the subtropical hot deserts, the relatively cold high latitude oceans, the very cold snow covered continents in high latitudes, permanently ice covered continents in the Arctic and Antarctic. Tropical air masses are warm and polar air masses are cold. The heat transfer processes from the arriving air masses changes the characteristics of the reached areas. Warm air masses makes the area warmer than what it was before, whereas the cold air masses turn the areas cooler than the original temperature conditions already prevailing. On the basis of characteristics of the surface, they are continental and maritime. In addition to all the mentioned above, a large variety of secondary types of air masses are categorized. For example, equatorial or Mediterranean, sometimes there is a letter K or W attached to the two letter initials indicating whether the air is warmer or colder than the surface of origin of air mass. The colder is more stable than the warmer. Types of air masses on the basis of source region. Now, based on temperature conditions. Based on temperature conditions, air masses can be listed into two categories as follows: polar, that is cold, and tropical, that is warm, and polar air mass, cold. An air mass with temperature lower than that of underlying surface, which is generally associated with instability and high atmospheric turbulence is termed as cold air mass, polar or arctic. The centers of the cold air masses are associated with high pressure on surface weather maps. They are heavier and denser cold air which pushes they are heavier and denser cold which pushes in under the warm air and rapidly forces it upward at a sharp angle, which results into steeper wedge than a warm front. They generally originate in the following regions: Arctic Ocean, cold and moist; Siberia, cold and dry; northern Canada, cold and dry; southern Ocean, cold and moist. Now, tropical air mass, warm. A mobile warm air mass is warmer than the underlying surface, generally associated with stable weather conditions. The center of very warm air masses appear as semi-permanent regions of low pressure on surface weather maps. It creates a series of wide bands of weather due to east movement of light warm air. Owing to its instability and temperature, it is as high humidity, hence these fronts are accompanied by cloud and precipitation. Based on the temperature of the surface area over which the air masses moves, same air mass can be called as cold or hot. They generally originate in the following regions: tropical deserts, warm and dry; tropical oceans, warm and moist. Based on latitudinal extent, air masses can be classified into various categories based on the source of origin and latitudinal extent. Based on the source of origin, air masses can be broadly classified into 5 categories. Air masses found in the tropical regions are warm, while in the polar are cold. The process of conduction or convection for transfer of heat helps the air mass to alter their characteristic slowly by migration, movement, or even at the same place. After looking on the basis of origin of air masses, theoretically many types of air masses can be listed, but in reality certain types of air masses are not possible or they are very weak and hence not considered. The abbreviations are sometimes used on weather maps to show the air masses over an area, particularly when the air mass have moved from their source regions. Air masses are practically identified at arrival and not at the origin source. Their arrival in different areas create distinct differences and hence their well demarcated boundary zones become apparent. Maritime Tropical. The source of this air masses are the subtropical anticyclones high pressure cells which persist throughout the year over the ocean about latitude 30° north and south latitudes. They originate from tropical and subtropical oceans like Atlantic and Pacific to Mexican Gulf. They are distinctly characterized during summers and winters, influencing the local climate. The air is warm, unstable and humid owing to warm water from seas beneath them. The air absorbs abundant moisture from the lower layers during summer, as the ability to absorb moisture is more in high temperature. After that, the stable air starts moving upwards from subtropical to higher latitudes and slowly starts cooling down due to contact with the cold sea and landless over which they pass. Slowly starts cooling down due to contact with the cold sea and landmass over which they pass. It results in reduction of normal lapse rate inverse, which increases stability and minimizes the turbulence. This cooling process from the lower layer gradually increases the relative humidity and the dew point is reached. The combination of these two factors produces fog and light drizzle to steady rain with the formation of stratus clouds. Here winter are mild and overcast condition accompanied by fog. This air mass invades hot continental parts and moves over the warmer seas in summers, which shows unstable characteristic with heavy rain. Majority of the eastern coastal parts of mid latitude receives maximum rainfall from this air mass. On the other hand, summer witnesses high temperature and humidity, which is accompanied by cumulus cloud and convectional rain. Continental tropical. These are hot, stable and dry winds that originate from tropical and subtropical desert area of North Africa, Sahara, Asia and Australia. These tropical continental dry winds originate from North Africa in winters, locally known as Harmattan, and are found in western drier margins of North America, USA in summers. These air masses generally do not extend beyond their sources. These types of air masses also originate from drier parts of These types of air masses also originate from drier parts of Australia. This air remains hot and unstable during summers and dry throughout the year with minimum humidity. High temperature and low humidity leads to high condensation level with no rainfall despite being in unstable zone. On the other hand, in winter, the air remains warm and dry but is stably stratified as it is found in anticyclonic zones with descending air. This stable wind hardly moves and thus it is localized, but when it moves towards cooler surfaces, its stability increases where it meets cold air masses. Such front occurs in the Mediterranean region. Overall, this air mass is dry throughout the year with scanty rainfall, unlike tropical maritime. Continental polar. As the name suggests, these air masses originate from polar areas like Antarctica, Arctic basin, Eurasia and northern North America. These air masses are dry, stable and very cold. Here the wind circulation is gentle and divergent. The winds are very dense and cold, mainly due to distance from the warmer water bodies, oceans, and continued prolonged terrestrial radiation. These winds are warm, less stable in summers with less or no prevalence of anticyclonic winds. Winters are frigid, clear and stable with meager cloudiness leading to precipitation in the form of snow or ice. Maritime polar. Maritime polar air masses originate from the oceans located across 40° and 60° latitude. Such continental polar masses moves over warmer water bodies like oceans, get heated up and absorbs moisture owing to increased temperature is referred to as maritime polar air mass. This region is characterized by cool, moist and unstable air. These regions are the regions which cannot lie stagnate for long. Summers are stable, clear and fair in this zone, while winters are characterized by high humidity, mild temperature, overcast skies conditions and occasional fog and precipitation. Continental Arctic. These air masses form over large area of snow and ice, typically near to poles in both the hemisphere. Arctic air masses tend to form during winter December to to March in the northern hemisphere and June to September in the southern hemisphere, when the poles are quite cold and without much insolation. Convergence of air masses and fronts. Different air masses originate and move out from their sources, but they all eventually meet in a region of convergence, zone of low pressure. At the interface zone, both cold and warm air masses meet, and it results only marginal mixing. The air masses primarily retain their own characteristics in the upper layers. It is unaffected and undisturbed. The instability and turbulence occur in the lower atmosphere near the Earth's surface. This phenomena of meeting and mixing of different air masses by convergence results in occupying the space of warm air mass by cooler and denser one. The warmer and lighter air masses shift over colder and heavier one. This ascent and convergence of fronts results in condensation and precipitation. The intensity of disturbances that accompanies this process of convergence is proportional to the humidity and temperature. Generally, heavy storms are common phenomena when polar air mass converges with subtropical air masses, stationary fronts. When a frontal system stops moving forward, a stationary front occurs. Stationary fronts may result from the stalling of either a cold or warm front and may remain stationary for several days. When a stationary front starts to move again, it may be either a warm front or a cold one. The discontinuity of temperature often weakens and the front simply disappears. In a stationary front, the weather conditions are fair and stable. Occluded fronts. An occluded front develops during the latter stage of dissipation of a depression, when the combined front of the air mass is detached from the ground. There are two types of occlusion: cold front type and warm front type. Occlusion takes place when a mass of warm air is pushed upward and removed from the ground by dense mass of cold air. The warm sector diminishes and the cold air mass completely undertakes the warm sectors on ground. Thus, a long backward swinging and occluded front is formed, which could be a warm type of cold occlusion. Weather along an occluded front is complex, a mixture of cold front type and warm front type weather. Air mass modification. The properties of an air mass influence the area of its occurrence. Air masses normally migrate from their source regions to other nearby surrounding regions. The moving air mass undergo two types of air modification. They are thermodynamic modification and mechanical modifications. Thermodynamic modification. Thermodynamic modification is caused by transfer of heat from moving air mass to moved place simultaneously, gets modified by moved place by acquiring the characteristic of that area. Thermodynamic processes include such effects as heating from below decreases the vertical stability. Other includes evaporation of water into air. Other includes evaporation of water into the air masses from below or into the intermediate layers by precipitation from overlying moist air layers. The extent to which an air mass is modified depends upon the initial temperature, moisture conditions, the path taken by masses, the path taken by air masses, the nature of underlying area, and time taken or duration of the travel. An air mass moving over a surface that is warmer than the ground temperature is bound to be heated from the below with consequent steepened lapse rate and stability. These changes create the chance of condensation and precipitation. An air mass moving over the colder surface is cooled from below. This condition favors the formation of surface inversion, which increases the stability of the air masses. Under such conditions, formation of the clouds and precipitation is not possible. As the polar air masses move out of their sources, as the polar air masses moved out of their source regions, they tend to become more and more stable. The tropical air masses, on the other hand, undergo the second type of modification and develops an increased stability. Thermodynamics changes are brought about by increased evaporation. The moisture may be supplied either from the surface or which the moisture may be supplied either from the surface over which the air is moving or by precipitation from an overlay area or by precipitation from an overlay layer of the air mass itself. Mechanical dynamic modification. An air mass may undergo changes due to any of the following reasons: turbulent mixing caused by eddies or convection, large scale dynamic effect on in lapse rate, divergence, convergence, subsidence or sinking. In subsidence and latent spreading, movement down from above colder air masses, descent from high elevations to lowlands, lifting over colder air masses to compensate for horizontal convergence over elevations of the land, advection of new properties aloft due to shearing action of the winds, mechanically induced turbulence resulting from frictional effects at the surface may cause through mixing, often to a considerable height. Heat and moisture are transferred from the surface to various layers to atmosphere, thus modifying air masses considerably. Large scale divergence or convergence near or above the surface may cause upward or downward movement of extensive portions of the atmosphere and affect atmospheric stability. A descending air mass, as one descending on the leeward side of a physical barrier, becomes more stable by subsidence. Lifting of an air mass in the case of orographic or frontal uplift renders it more unstable. One can understand a lot about weather conditions from air masses just by looking at their names and origins. Maritime air masses possess good amount of moisture. The air blowing over the warmer ocean regions picks up moisture from humid moisture laden winds as it travels along. The air masses wind carries atmospheric moisture which oceans the air masses wind carry atmospheric moisture from oceans to continents and causes precipitation over land masses. In maritime Arctic and polar regions, the moist air is cool and the maritime tropical air mass produces the warm and humid condition. In contrast, continental air masses produces dry weather. This is because the continents just can't compete with the oceans when it comes to moisture. The continental Arctic and polar air masses produce dry and cold weather in the winter and pleasant weather conditions in the summer. Air masses transport latent heat, thus removing the latitudinal heat balance. Most of the migratory atmospheric disturbances such as cyclones and storms originate at the contact zone between different air masses and the weather associated with these disturbances is determined by characteristics of the air masses involved. Summary and conclusion. An air mass is a regional parcel of air developed over an area where it has remained for a longer period and gained a particular temperature and moisture conditions. There are types of air masses. They are tropical maritime, tropical continental, polar maritime and polar continental. Additional extremes are polar maritimes and Antarctic continental. Continental air masses are relatively dry and maritime air masses are relatively humid and are classified on the basis of moisture availability. They generally originates in the following regions: Arctic Ocean, cold and moist Siberia. They generally originate in the following regions: Arctic Ocean, cold and moist Siberia, cold and dry Northern Canada, cold and dry Southern Ocean, cold and moist. Polar maritime air is more common in both hemispheres with source region in high latitude oceans. Polar continental air occurs in northern hemisphere while Antarctic continental occurs in southern hemisphere. Tropical maritime air mass is common in both hemispheres, but tropical continental air is less common due to lack of large land mass in the subtropics. India becomes a source region for tropical continental air in winter due to cold prevailing conditions. In the summer, the high pressure over Siberia combined with Himalayan mountain chain restricts movement of continental tropical air mass northwards. Air masses are modified by the Earth's surface. If the surface is colder than the air mass, the stability of the air will be decreased, and if the surface is warmer, it will be decreased, and cloud formation and precipitation may result. Thank you very much.